හොඳම හරියදී හිර වෙන්නේ නැති වෙන්න SLT Mobitel fiber connection එකක් ගන්න. Netflix බලන්න. ලංකාවේ bestම internet connection එක SLT Mobitel fiber connection. තනතිල්ල දෙසින් සිසිල් සුළං රැල්ලක් හමා යනවා. දිව එනවා පන්දු යවන්න. පහරක් එල්ල කරනවා. ඩීප් මිඩ් විකට් කලාපය ඔස්සේ කිසිම සමාවක් නැම ලකුණු 4යි. ටෙස්ට් තරග ඉතිහාසයේ ඉනිමකදී ලබාගත් වැඩිම ලකුණු ප්‍රමාණය ලබා ගැනීමට පිතිකරුට අවශ්‍ය වන්නේ තවත් ලකුණු 34ක් පමණයි.
ලැග් වෙවි ප්ලේ කරන එකට වැඩිය හොඳයි ඉනිම ඩික්ලෙයාර් කරලා දාන්න.
ලැග් වෙවි ගේම් ප්ලේ කරලා ඇති වෙලා නම් ගේමින් වලට ලංකාවේ bestම ඉන්ටර්නෙට් කනෙක්ෂන් එක SLT Mobitel fiber connection එකක් ගන්න.
Good evening, everyone, and a very warm welcome to all of you. On behalf of the RoboGames Organizing Committee, I am delighted to welcome students, teachers, and parents to the RoboGames 2025-2026 School Category Workshop session. Today's workshop is designed to give you clear guidance, practical understanding, and confidence to take part in RoboGames, especially for our school category participants. Thank you for taking time to join us, and we hope this session will be both informative and inspiring. To guide us through today's workshop, we have a speaker who brings strong experience and deep involvement with RoboGames. Our speaker will walk you through key aspects of the school category, share practical insights, and help you understand how to prepare effectively for the competition. It's my pleasure to invite Mr. Sasmitha Jayasinghe, former technical lead for RoboGames 2024 and the team captain for Team University of Moratuwa for RoboCon 2025, to lead today's session. Please join me in welcoming our speaker. Over to you.
Am I audible? Am I audible? Okay. So good evening, everyone. Dear OC as well as dear competitors. So today we are going through the introduction to Webots and how to simulate a kind of program through Webots. Okay, let's start. So let's move to the first our presentation. Yes. So why Webots? So all of you know that the Webots is a kind of realistic robot simulation. It means you can simulate a kind of robot using this platform, like you are practically working with that robot or that setup. And the next one is multi-language support. It means you can code using Python, C++, C using this simulation platform. And the third one is building robots and sensors. You can include robots as well as sensors inside this Webots simulation platform. And fourth one is open source and cross-platform, because you can download and install it freely. The most special thing is you can use this Webot platform to experience the robots where what you can't buy. Yeah, you can't buy actually. For an example, this year's previous years, we are using the robot called EPA. You can Google it and ask how much is this. I think the last time it's around $850. So think about that. That's a massive and very expensive. But in Webots, we can use it as a simulation and we can practically use it for our activities, and we can test it and experience that robot. Then it will be good for us to our future activities. So that is why we are using Webots for simulation. Am I? Yes. Is it okay right now? Can you hear me?
Yes, we can hear you.
Yeah. Okay. Sure. So I will continue. Yes, that's kind of things we can get some kind of advantages using the Webots platform. Okay. Next, move to the next slide. Yes. So next part is installation. I will show you how to install Webots for your local machine. Yes, I think you can see my screen, right?
Yes.
Yeah, okay. Sure. So first of all, you need to go to the Google and Google cyberbotics, right? Just cyberbotics and type. Then you can see this section, cyberbotics robotic simulation with Webots. Just you need to click it. Then you can see the download button and make sure what is the operating system you use. Generally, it detects the operating system as Windows or Mac or Linux. But if it is wrong, please check it and select the operating system related to you. Then you can press download and download the file. Next, you need to click it and install it. So I already did that. Then next, move to the next slide, please. Yes, how to load an environment. So I will show you how to load an environment through this. First of all, after installing it, you need to search like this, type Webots, then you can see Webots. I'm sorry, my laptop is a little bit stuck, and I will try again. I think right now you can see it. Yeah. So this is the section you can see after you click in and open the Webots platform. So first of all, you need to go to the then new project directory. Then new project creation. Next, then you can name your project as let's name our project like IESL RoboGames. Next, you can name your projects. For an example, I name this workshop. And remember to click at the rectangular area. This is a kind of demonstration and simulation from the very beginning. Then you can get an idea how the Webots working and how we can use Webot for our activities. So next, finish. Yes, this is the platform you can see, the same platform I used. So this is the rectangular area, you can see it. So this is the environment you can load, and I will show you at the latter part how to load your compression environment for the Webots. Right now, let's start in demo using this platform. Yeah. So first of all, we need to identify the objects. In Webots, the objects are nodes. So you can see at your left side, there is a bar, as well as in the top side, there are some kind of icons. So this is the icon. You start the simulation, you can pause it or you can start it. this icon, you can go to the first place before you save. No, before you save, no, after you save. It means if you save this file, it will begin from that place. If you don't save this thing, it will go to the first beginning. Okay, so you can move this like this and like this. It is like if you are working with what Autodesk or AutoCAD, just like that, you can move this rectangular arena by using your mouse. Yes, then let's start with adding some kind of object for this. First of all, you need to click rectangle arena. Then you need to press this button. You can see add a new object or import an object. So just press it, and then in the base nodes, you can see some kind of base nodes. For now, we are using kind of a shape. So first of all, I'm clicking solid because you need to, if you are inserting some kind of solid thing, you need to, first of all, you need to click the solid and create a solid. Then you can create a shape inside that solid. Yes, solid was created. Then inside that, you can see children. So inside the solid node, we are creating children and we can use shapes as children. Then I am put a shape. Yes, you can see right now there is a shape under children under solid. So we need to keep this hierarchy because then we can start our coding and we can clearly mention those things inside Webot simulation. Other than that, it will be issued for you to coding and other things. So think about that. The hierarchy is more important, and I think your world was given by the organizing committee. There also you can see this kind of hierarchy. So you need to go inside the nodes to identify what are the nodes inside the whole project. Inside the shape, you can see geometry null, appearance null. So first of all, just click on geometry null, then you can see some kind of shapes inside base node, box, capsule, cone, cylinder, like that. So right now I am creating a box. I add it. Now you can see there is a box on my rectangular arena. Then I can change the colors and things. Just click it and appearance null. Then you can say PBR appearance. Just tap. Then inside that PBR appearance, you can see I can change the color, transparency, roughness, and those kind of things. Let me show how to change color. I just put them 0, then it would be black. Yeah, you can see a black object on the rectangular arena. And if you like, if the rectangular arena is so small for you, you can change that also. Yes, you need to go to solid rectangular arena, and here there you can see the flow size. You can increase that to X direction as well as Y direction, your rectangular arena. Then you can increase your area of the arena. I just keep into 2. And then I'm going to again to solid under shapes and transparency. Then first of all, this is I am starting this simulation from the beginning. So this is not actually the real environmental object. So we need to insert the real environmental qualities and features for those objects, like gravity power. Other than that, it would be, for an example, I can do this. Yeah, you can see right now it is not on the arena, it is on the air. So in the real environment, we can't put a kind of a box at the air like that. So we need to add some kind of physical features. Physical features, it means physics regarding features for this. We have option like this, physics null. Before that, we need to bounding object, base object box. Then you can see it was bounded. Then we can add physics. Yes, right now you can see. Yeah, it is not flowing through the air. It is right now on the rectangular arena, and you can increase the mass. So yeah, yes, through that you can increase the mass. It's like that. This is fine. Yeah, it's okay. It is object it is regarding the object creation. So you can create any kind of spheres, shapes, any kind of thing on this rectangular arena. So then I'm moving to how to create a robot on this arena. Generally, in your task, you are using epoch. Is my screen is some kind of triggered or something? Okay.
No, it's all fine.
It's okay. Okay. So I'm continuing. Then yeah. Let's move to robot. So like in the previous part, just click the rectangle arena, and next I am adding a robot as the basic type. Inside the robot, inside the children, I'm going to add the epoch. As you can see under protonodes, it is robots, and inside the robots you can see GC Tronic, and then you can see epoch. Click epoch robot and add. Then you can see the robot is inside the middle, and I will take it outside. Yes. The robot also doesn't have some kind of physics features, so I will add that for those in the robot. Right now you can see it was moving. It follows this commands. You can see under robot, under epoch, this is the controller. Right now it is following epoch avoid obstacles code. This is the code you can see at the right side of you. This is the code. So right now it is following this code. Yeah, those are the fundamentals of creating a robot. And if you like, you have to do, you can't use this kind of code. You need to create your own code. What you need to do is, you can create this section too. You can edit this and save it inside the relevant folder. Or other than that, you can create it you can create the coding file somewhere else and copy and paste to the relevant directory. After everything, however, you need to place that code inside the directory where you can see these things. Select this thing. It means epoch code obstacle. Let me show you. It will be good thing. Yes, right now download IESL RoboGames. This is the words. Then controllers. You can see right now there is no controller. So you can save this controller for there. Save. Okay. It was saved. And right now you can select it on the epoch avoid obstacle one. Okay. So this is following that coding file. The robot is following that coding file. So like that, you can insert any kind of coding file using that system. Or if you are using VS Code, you can create the code anywhere else, and you can copy and paste that code file to the relevant directory like I did before. Okay, then I will show you how to add a sensor for the epoch robot. For an example, yes. First of all, you need to create inside the epoch. Basically, we need IR sensors for epoch because I think your challenge is regarding detecting the black line as well as line following robot. As then you need to push the obstacle. I will show you how to add kind of IR sensor for that. You need to go to the epoch. Under epoch, you can see ground sensor slot. Then just click that add icon. Then under base node, you can see distance sensor. For epoch, you can't add or insert IR sensor directly. You need to follow this path to add an IR sensor to epoch robot. First of all, I will stop the simulation. Other than that, it would be hard for me. Yes, base nodes, distance sensor, add. then you can see under the ground sensor slot under epoch robo, distance sensor is added. Then under that you can see type is here. It is type right now generic. I can change it to infrared. So right now it is converted to infrared. Right now you have infrared sensor, and if you like, you can change the name to. I put it IR1. Like that, and you can change translations of your IR sensor as well as others too. I just give you a brief idea and brief knowledge about the basic knowledge about the how to use Webot platform as well as how to use robots in Webot simulation and how to use objects. Then if you need to see the robots sensors are working, let me show you. You can use view button, operation rendering, and inside there you can see show distance sensor rays. Then you can see the sensor rays there. And this is the IR sensor we added recently. You can see it. So this is the IR sensor. So right now it is directed to the in front of the robot. So you can change the you need to go to distance center, and you can change translations and rotations if you like. You can change those things, and you can add physics that too. Likewise, you can change those things. I think your OC will give you some kind of world and protos regarding this, so you don't need to worry about these things. But for your knowledge, I want you to know that the things are going this kind of flow. Robot under this robot, under there's a epoch. Under that epoch, you can see ground sensor slot and distance sensor. That flow will be managed inside the code too. Yeah, this is it, and then you can try a simulation like that. I will wait a minute. I create some kind of thing. Again, start. Yes, I think now you guys see this. Sorry for delay, it was stuck. Yeah, this is some kind of that thing, and you can see right now it is black in color, and I created previously, same as I showed you before. And this is the code generated by me. You can see inside the code. I call the IR1 my created sensor, and right now I need to run this file. What you need to do is you need to paste yeah, my controller C, save it. Yeah. Then you should need to do this because right now just stop this and create the epoch. You must go to the epoch robot, and I told you you need to change the controller. You need to select my controller. Okay. uh, then you can build. So some kind of issue has been happened. Let me start it again. Yeah, right now it's good. So first of all, stop this and you need to save this. Again, I will show it. My controller sees also fine. Yes, you need to save what you are doing to the code. Other than that, it will not take. Then you must build this. You can see the code is building and finish, cancel. Then you must select, right now it is epoch is this one, and with this, and I use my controller. Yes, right now you can see the sensor is working as well as the robo is working, but there is a problem. You need to identify those kind of issues here because my sensor is still at the start of at the bottom of the robot, and the sensor will target at the front area. The problem is you can see the wall of the rectangular arena also some kind of dark color. That's the issue. Is directly identify it as a dark color. So those kind of things you need to manage with your competition. This is just a simulation. I want to show that to you too about that. The code is working, the sensor is working, but sometimes you need to manage and you need to identify what are the code and what are the outside things that can bother your program like this. So the code is working. What I want to do is I want to robot to detect there's some kind of black area. He detected it, but problem is he detected this wall as his black area, not this object. So like that, you have to manage that things through your studies and code references about Webot. Because this is not a real environment. We need to create all the real environment features and other things inside the Webot simulation. Then you can give a good code and then you can run this simulation without any issue. That's the thing. And yeah, I missed something. I want to show you how to add a controller. Yes, this is the way you can add the controller. New robot controller. And next, then you can select the language. I think this time you have C or C+ languages. So you should use those kind of language for your codings. Next, you can select both of them, no issue, but recommended Webots GCC. And you can name it as finish. Yes, this is the free one. You can start your coding through here. Other than that, you can use the VS Code and copy and paste the right directory true. No issue. Anyhow, the thing is you need to identify here. The select option, the new one need to be visible here. Other than that, the epoch cannot take your code or follow your code or instructions. So it would be huge issue for you. So please follow these steps. Then you can complete your task very easily. Yes, that is from demo and installation, demo section and installation section. This is small concept, and but you have to learn a lot of things regarding that because your task is. I show you task 2. I think yeah, this is your task. You can see you need to follow the black line and push the relevant boxes to relevant areas. Then what you have to do is you need to download these things. I think OC gave you the will give you the instruction to follow. Then you need to download that specific files, and you need to place those specific files in the specific file. Include these things. Yeah, worlds and protos. You need to replace your project's worlds and protos by using the competition worlds and protos, then you can just need to go worlds, and there you can see my first school task or school task or some kind of thing. Then you need to click that. Then you can directly move to this world. So you need to start coding through this, and you can see in this robot. I will show you the IR sensors. This view. Version rendering. Yes, I think you can see this has 5 IR sense. Sorry. Yes. So this robot has 5 IR sensors. You can see that. So you need to be aware about that and how the sensors can be used to complete your task. So uh, that's it for today. So if you have any kind of question regarding demonstration and Webots installation or Webots, please put those messages inside the chat bot. Oh yeah, then I can answer about that. If you have any question or any problem regarding the competition or competition rule, just put a message. Then the team lead of IESL RoboGames 2026 will answer you. So that's for today from my part. Yeah, that's the end of Webots. In the internet also you have a lot of resources, a lot of YouTube tutorials as well as documentations. You can follow them, and hope you do well in your competition. And yeah, best of luck for all of you. Thank you very much, and thank you the OC to give me this chance. And thank you. Good night.
Thank you very much for that informative and engaging session. We will now move into a question and answer session. Students, teachers, and parents are welcome to ask questions related to the school category. Please type your questions in the Q&A chat, and we will take as many questions as time permits. Now let's start addressing some questions. I noticed the standard epoch model usually includes 8 distance sensors and light sensors around it. But our robot only has light sensors. Is it a mistake or a part of this task? Cause we can easily make box avoiding thing using distance sensors.
To answer that question, yeah, we may customize the epoch robot. So we are in the final round. We are planning an actual physical robot. So we try to make same sensors as in epoch robot as a physical robot. So that's why it doesn't have all the side sensors and has 5 IR sensors. Like if you look at the epoch robot, there is only 3 IR sensors, and the one we provided has 5 sensors. And also we only included one proximity sensor and a color sensor. Color sensor is usually as there is name as camera. So in the final round, the robot will only have one proximity sensor looking like forward face. So yeah, we customize the robot and you have to use only the sensor, only the distance sensor and other sensors we have provided to avoid the green box.
What actuators can I control?
You're on mute, Mal.
Sorry. Uh, so for as actuators, you have two motors, two wheels inside of the robot, and also as actuators, that's it. And as sensors, as I told you before, the five IR sensors and proximity sensor and a color sensor. So that's what you have there. And there can be other light like small LED lights and other stuff in the robot. But since the one we have provided is only the one in the physical robot, we expect you to only use those mentioned sensors and actuators.
Please explain the rules and conditions when it comes to programming our phase 1 bot and requirements that are expected.
So we have provided you the booklet and I can go through all of them. Like I can tell you the basics. So we have provided the Webots file. So the world is there. You don't need to edit anything. And what you have to do is only to change the program, like edit the code. And yeah, the about the task, like you understand what I'm saying, right? Just change the code and make the robot run according to that program. So about the task, it starts with the black square. Its name as start the square. So from that, I need to follow the black line, and when it meets the brown cube, so and then when it meets the brown cube, it has you have to the robot need to push the brown cube forward then until it meets the black square in middle. Then robot needs to turn around and follow the other path leading to the green cube. And when it meets the green cube, we need to like robot need to avoid the green cube and stops at the next black square named as N.
Whom should be contacted when problems related to installation come up?
So for as the technical support, we have given five contacts. So I will provide the contacts in the chat too. So you can contact them at any time, and they will help you with installation and Webots installation and any issues you will have in the process.
Is the only available simulation tool available is Webots, or are there any other alternatives?
So in simulations, there are many, but since we build the task around the Webots, we expect the task will be only made using Webots. තව සිංහල හෙවත් කියවෙන එක අහලා තියෙන හින්දා ඔයාලට උදව්වක් ඕන නම් අපි කන්ටැක්ට් එකක් දාන්නම් chat එකේ ඒ නම්බර්ස් ටිකට ඕනලා කතා කරන්න ඔයාලට කැමති සපෝට් එකක් අරගන්න පුළුවන්. ඒතකොට ඔයාලා ඉන්ස්ටලේෂන් එකේදී හරි නැත්නම් ප්‍රශ්නයක් ආවම නැත්නම් කෝඩ් එකේ සෙන්සර්ස් හරියට කන්ෆිගර් කරගන්න ප්‍රශ්නයක් ආවොත් එහෙම එයාලෙන් කන්ටැක්ට් කරගන්න. එයාලා අනිවාර්යෙන් ඔයාලට පුළුවන් තරම් උදව්වක් කරයි. As the question asks, do we have to use a physical robot for the final? And if yes, do we have to make one? So you don't need to make one. And yes, there is a physical robot for the final, and we will provide you the robot. We will send it to our school. That's how we have planned it. And you don't need to change any hardware or anything. You just need to program the robot. So there is another question. Uh, There's one question is you test your robot in a different environment in Webots world? Yes, we have, and it will include a T junction, and also they ask is brown box always before the green one. So yeah, we expect the brown box to be pushed before the green one, and the environment will be there. Like, environment will not change. So for final submission, world is as it is and it will not change. So you have to program according to that. So there is another question asking, can we get the recording of this meeting? Yeah, we are already recording through video, and we will give you the link and you can watch it again and complete the task while Sasmita explained the.
Can I use more IR sensors than default robot to do the project?
So please don't do that because we have, as we told before, don't change anything in the Webots file, in the Webots world. So changing any IR sensor, so adding any sensors will change that file. So as we told before, we only expect you to program the robot using C or C++ and provide that code as a submission.
Can we use any AI platforms?
So we will strongly recommend you not to use any AI platforms since this one is a learning process. And if you use AI or anything, like you are not learning it. There's no use in you are doing this competition. So we strongly say not to use anything. Yeah, you can ask if there is any question. You can ask our technical team, and they will help as much as they can.
Can we ask your help to solve our doubts in code?
Yes. I think numbers will be in chat, and you can contact any of them, and ask any doubts you have.
Explain the route of the robot that we have to follow.
So I will tell that again. Trevor, from the starting position in the environment, Trevor needs to follow the back line, and without turning to the left from the T junction, it need to move forward until it meets the brown cube, and Trevor needs to push the brown cube towards the black square, and once it's in the black square, Epoch Robo can turn around and follow the other path from the T junction. And from there, once it meets the green cube, it should avoid the cube and go around it and stop at the next black square. That is the complete task.
Can we use any programming languages?
Uh, you will we will only allow you C and C++ languages. So try to only use the C and C++ language.
We will give you another 1 minute to answer any questions. In any medium, you can ask any questions.
So someone asked about the submission process. About submission process, we expect you to have a video submission of the robots completing the task. So you have to screen record the robot completing the task, and also we need your program C code or C++ code to check whether your task is also working in our devices. And we also need permission, right? Permission from the school teacher or anyone you have linked in as mentor. And about the workshops, there will be another workshop in semifinals. So we'll see you in semifinals in another workshop. And I have to also remind the deadline. Deadline will be in February 20th. So make sure you submit everything before that date.
Thank you once again for addressing the question so clearly. To formally express our appreciation, I would now like to invite Mr. Tilakshan Balakrishnan, Vice Chairperson, to deliver the vote of thanks. Over to you.
Hope I'm audible.
Yeah, we can hear you.
So before I get to the vote of thanks, I just want to clarify a couple of things. So regarding we faced a couple of questions regarding the language barriers of doing the session in English. So we can help you out with regarding the language barrier. So you can reach out to us either in your native language, Sinhala or Tamil. And we have provided the details of the contact person in the group, and also we'll be providing them later. So please don't feel shy to reach out. We are here to assist you, and we are here to guide you throughout the entire process. Sorry, I think there was an issue with my internet connection. Now that I'm back. So regarding the guidance, of course, you can reach out to us in Sinhala or Tamil, and we'll help you out with that. So with that out of the way, let me proceed to the actual word of thanks. So first of all, I would like to thank our guest speaker for the day, Mr. Sasmita Jasinger, for taking the time off his busy schedule to come today with us to guide us in this session. I think all of us found the introduction to Webots really valuable, and we kindly thank him for his time and effort to understand the fundamental concepts of Webots. And following that, I would like to also thank our organizing committee for putting such a massive effort and undertaking into making sure that everyone had a wonderful session, and a huge shout out to them. And also, what would the session be without each and every one of the participants? So I thank each and every one of you all for showing up today, for your enthusiasm for learning for robotics. It's people like you whom without this event wouldn't have been a success. So thank you so much, and over to you, Idusha.
Thank you very much for those kind words. Before we conclude, I'd like to make a couple of important announcements. The deadline for initial task submission has been extended to the 20th February. Make sure to follow the submission guidelines which has been shared with you. If you have any questions regarding the submission process, feel free to contact the following people: Hasini Lavanya, Janshika Nyansekaran. With that, we come to the end of today's core category workshop session. Thank you to our speaker, organizers, teachers, parents, and all students for your active participation. Wishing you all the very best for successfully completing the initial task, and we look forward to seeing you at RoboGames 2025-2026. Have a wonderful day, and thank you for joining us.